owner of a mortgage can decide to repay early his debt before the contractual maturity, in most cases without suffering any penalty. The reasons could be truly various, financial or non-financial, and they don't seem to follow linear relations, thus they are difficult to be investigated.
The prepayment event is a significant risk for the bank. This can involve changes in the future expected cash flows and is obligation to manage. Hence, it is important to have a precise estimation of the future prepayment volumes.
To describe the prepayment phenomenon, the model estimates the conditional prepayment rate. It is the probability that a mortgage is prepaid during a given month. In particular, it is obtained by estimating the volume prepaid, which is the amount early repaid, divided by the total outstanding amount in such month.
The prediction of a prepayment event is a classification problem, which is traditionally addressed by a logistic regression model. This method supposes a linear relation between the features and the binary output. But since, in those scenarios, an irrational human behavior is involved, this cannot be a fully explanatory model.
Thus, we introduce an innovative approach. We exploit the deep learning technique that extracts valuable information from the features automatically from our data. As a black box, we implement an artificial neural network which tries to reproduce the structure of a human brain with neurons and synapses, creating nonlinear relations between the inputs and the outputs.
To improve interpretability, we select some features with strong economic meaning that could be easily derived also for future periods. Moreover, since prepayment events are rare, almost 1% of all the contacts, we perform an oversampling of the dataset, which means creating some artificial samples that replicate the true historical data.
We obtain the trend of the CPR during the years and we compare it with the historical curve. The orange graph represents the historical values. Let's analyze the blue one. The neural network catches very well the peaks. This is an example. However, it has some difficulties during the pandemic years.
Let's add the Logistic results. Logistic doesn't seem to catch the depression of 2012 or 2014. In the graph, it seems that the neural network can catch better the prepayment events. For example, let's suspect that it is able to find correct.
As we have seen, the prepayment rate is subject to high variability, ranging between 2 and 30% during the years. Nevertheless, this trend can be well explained by our model. It is evident that the neural network outperforms the more classical logistic regression. The revolution is in the nonlinearities and in the autonomous extraction of features, breaking the conventional linear approach and bringing to a more precise estimation model.